For centuries we have gazed at the stars, dreaming of what lies beyond. But here's the question, will humanity ever reach another star? Will we break free from our cosmic prison and set foot in another solar system? Or are we doomed to be forever trapped around our sun? The answer may be closer than you think and stranger than you can imagine. Humanity has always been driven to explore, to push beyond the known world. But space is the final frontier, and the stars, they are unimaginably far. Today, we'll explore the mind-blowing challenges of interstellar travel, the groundbreaking technologies that might get us there, and whether we are destined to remain a planetary species, or become true cosmic travelers. Space is vast, far beyond what most of us can truly comprehend. The nearest star system, Alpha Centauri, is over 4.24 light-years away. That's nearly 40 trillion kilometers. To put that in perspective, if you shrank the entire solar system to the size of a dinner plate, Alpha Centauri would be nearly 5 kilometers away. Let's put this in perspective. If you drove a car to Alpha Centauri at highway speeds, it would take over 450 million years. Even the fastest human-made object, NASA's Parker Solar Probe, moving at 700,000 kilometers per hour, would take over 6,000 years. That's longer than all of recorded human history. So, if conventional rockets won't cut it, how can we ever hope to cross the interstellar abyss? The technologies that could take us there. One of the earliest ideas for faster space travel was nuclear propulsion. The Orion project, proposed in the 1950s, suggested detonating small nuclear bombs behind a spacecraft, using the explosions to propel it forward. In theory, such a ship could reach 5% of the speed of light, cutting an interstellar journey to just a few centuries instead of millennia. But the risks? Immense. The fallout alone made this idea politically and environmentally unfeasible. A more practical idea is nuclear fusion propulsion. Unlike nuclear fission, which powers today's reactors, fusion generates much more energy and could theoretically push a spacecraft up to 10% of light speed. That would get us to Alpha Centauri in about 40 years. But we still haven't mastered nuclear fusion even for power plants, let alone for spacecraft. One idea that has already begun development is the light sail. Instead of carrying fuel, these spacecraft would be pushed forward by powerful laser beams fired from Earth or the Moon. A project called Breakthrough Starshot aims to launch tiny, gram-sized probes to Alpha Centauri at 20% the speed of light, reaching it in just 20 years. But here's the catch, these probes would be microscopic. How do we send humans that way? For now, we don't have an answer. Fusion engines could be the first real method for large-scale interstellar travel. By fusing hydrogen atoms like the sun, we could generate immense thrust with minimal fuel. But what if we went even further? Antimatter, the most energetic substance in the universe. When matter and antimatter meet, they annihilate completely, converting mass into pure energy. A single gram of antimatter could generate as much energy as an atomic bomb. If we could harness this power, we could travel at 90% the speed of light, reaching Alpha Centauri in just 5 years. The problem? We currently produce only nanograms of antimatter at a time. Scaling up production would require a level of technology we don't yet possess. Warp drives and wormholes, fascinating concepts that challenge our understanding of space and time. But what if we didn't need to travel at all? What if we could bend space itself? This is where warp drives and wormholes come in. The Alcubierre drive, first proposed in 1994, suggests that space-time could be compressed in front of a spacecraft and expanded behind it, effectively allowing it to move faster than light without breaking physics. And wormholes? If they exist, they could serve as cosmic shortcuts, but keeping them stable would require exotic matter with negative energy, a concept that remains purely theoretical. For now, these ideas belong in the realm of speculative physics. So, when will we make our first interstellar journey? The truth is we're still in the early stages, but the Breakthrough Starshot project could send robotic probes to Alpha Centauri within the next 20 to 30 years. fusion propulsion might become feasible by the end of this century, and with enough breakthroughs, a human mission to another star could happen within a few centuries. Why does interstellar travel matter? Because one day, Earth will no longer be habitable. Whether through climate change, cosmic disasters, or human actions, we must become an interstellar species to ensure our survival. And beyond that, the urge to explore, to go beyond, to see what's out there, that is what makes us human. So, will humans ever reach another star? The journey will be difficult, but if history has shown us anything, it's that we always find a way. What do you think? Will we ever make it? Let us know in the comments below, and don't forget to like and subscribe for more deep space content. Until next time, keep looking up.